Hello guys, today I will explain network topology, that is chapter 3 of networking. So first, what is topology? Network topology is the arrangement of the elements, link, nodes, etc. of communication network. Network topology can be used to define or describe the arrangement of various types of telecommunication network. Then topology types. First physical topology and then logical topology. What is physical topology? It defines how devices are connected in the network. Then what is logical topology? It defines how data travels through a network. Different types of physical topology: bus, ring, star, tree, mesh, hybrid. Here are the some types of physical topology. Different types of logical topology: token ring, token bus, CSMA CD, CSMA CA, demand parity. Here are some logical topology. Then bus topology. So what is bus topology? Bus topology, here are you guys see is this is a definition of bus topology. Bus topology carries transmitted data through the cable because data reaches each node. The node checks the destination address, MAC and IP address to determine if it matches their address. If the address does not match with the node does nothing more. But if the address of nodes match to address contained within the data, then they process knowledge. In the bus, communication between nodes is done through a for most network cable. Key feature of bus topology. Here are key features you guys just see. An efficient bus architecture is established and each station is connected by a single backbone cable. There are two requirements. Initially, the nodes are connected to the backbone cable directly, or they use a drop cable to help them connect. The well-known access method for bus topology is called CSMA, carries sense multiple access. Best practice for designing bus topology: plan for scalability, use good quality cabling, and implement redundancy. Here are you guys are see this is the best practice for designing bus topology. Here are terminate the bus properly. Then I go to advantage of bus topology. Here are some advantage of using bus topology. It is the easiest network topology for linearly connecting peripherals or computers. It works very efficiently well when there is a small network. The length of cable required is less than a star topology. It is easy to connect or remove device in this network without affecting any other device. Very cost effective as compared to other network topology, mesh and star. It is easy to understand topology, easy to expand by joining the two cables together. Disadvantage of bus topology is not good for large networks. Identification of problems become difficult if the whole network goes down. Troubleshooting individual devices issue is very hard. Need terminators are required at both ends of the main cable. Additional devices slow the network down. If the main cable is damaged, the whole network fails or splits into two. Packet loss is high. This network topology is very slow as compared to other topologies. Then what are the components of bus topology? The major components of bus topology include backbone cable, terminator and drop lines. Is there a server in bus topology? In a bus architecture, every node is directly connected to a single main cable. The network's backbone is the primary cable. One of computer is work as a server from the network. Is bus topology half duplex or full duplex? Bus topology is half duplex. What happens if two devices attempt to transmit data simultaneously in a bus network? Data transfer in a bus topology is accomplished by a procedure called collision detection. A signal sent by one device on the network is broadcast to all other devices in the network. When two devices attempt to transmit data simultaneously, there is a collision that result is distorted signals. Here a thicknet coaxial diagram you guys are see. Then ring topology. In a ring topology, all computers are connected via cable that loops in a ring or circle. A ring topology is circle that has no start and no end. Because there are no ends, terminators are not necessary. In a ring topology, signal travels in a one directional on a ring while they are passed from one computer to the next, with each computer regenerating the signal so that it may travel the distance required. Then advantage of ring topology. Signal degeneration is low because each workstation is responsible for regenerating or boosting the signal. Because each workstation in a ring topology regenerates the signal. The signal is stronger when it reaches its destination and seldom needs to be retransmitted. Disadvantage of ring topology. If one computer fails or the cable link is broken, the entire network could go down. Isolating a problem can be difficult in some ring configuration. If you make a cabling change to a network or move a workstation, the brief disconnection can interrupt or bring down the entire network. Here are some disadvantages of ring topology you guys are see. Here are diagram of ring topology. Dual ring topology. In this topology, two rings are used. The first ring is called the primary ring and the second one is called the backup ring. If the first ring is sending a signal clockwise, then the backup ring will send the signal anti-clockwise. Advantage: redundant connection is available. If one ring fails, another ring will transfer data. Disadvantages: more cable required, more NIC cards are required, very complex network. Here are dual ring topology diagram you guys are see. Then start topology. In a start topology, all computers are connected through one central device known as a hub or switch. Each workstation has a cable that goes from the network card to the hub device. One of the major benefits of a start topology is that a break in the cable causes only the workstation. It does not affect the entire network. Start topology are very popular topology in today's networking environments. Then advantages of start topology. Here are you guys are see advantage of start topology. Scalability and easy of adding another system to the network. If you need to add another workstation to the network with a start topology, you simply connect that system to an unused port on the hub. If there is a break in the cable, it affects only the system that is connected to that cable. Centralizing network components and can make an administrator's life much easier in the long run. Centralized management and monitoring of network traffic can be vital of to network success. It is also easy to add or change configuration because all of the connection come to the central point. Disadvantage: if the hub fails in the start topology, the entire network comes down. So we still have a central point of failure, but this is a much easier problem to troubleshoot than trying to find a cable break with a bus topology. Another disadvantage of star topology is cost. To connect each workstation to the network, you will need to ensure that there is a hub with an available port. We need to ensure you have a cable to go from the workstation to the hub. Today, the cost is increasingly less of a disadvantage because of the low price of devices such as hubs and switches. Here are you guys are seeing mesh topology. Then I explain mesh topology. A mesh topology is not very common in computer networking today. In a mesh topology, every workstation has a connection to every other component of the network. It is mainly used for redundancy, alternative connection, and fault tolerance. Here, more cables are required. Twisted pair and fiber optic both media can be used. It has two types: full mesh and partial mesh. Full mesh connects connection to all devices with a direct link is mandatory. Partial mesh connection to all devices with a direct link is optional. Advantage of mesh topology. Mesh topology is fault tolerance. If there is a break in a cable segment, traffic and can be rerouted through a different pathway. Because there are multiple pathways to send data from one system to another, this fault tolerance means that it is almost impossible for the network to go down due to cable fault. Disadvantage of mesh topology: cost of the additional cabling, network interface to create the multiple pathways between the edge system. A mesh topology is very hard to administer and manage because of the numerous connection. Tree topology: it is a combination of linear bus topology and star topology. It was introduced to upgrade company from bus topology to star topology for better speed and performance. Here hub is used to connect both the topologies. Hub is having two types of ports: BNC and RJ45. BNC to get connected with bus topology, RJ45 to get connected with star topology. Later on switch was introduced replacing hub. Then hybrid topology. It is important to note that it is typical for network to implement a mixture of topologies to form a hybrid topology. Type of hybrid topology: star bus topology, in which a number of star topology are connected by a central bus. This is popular topology because the bus will connected hubs that are spread over distance. Then star ring topology. The star ring topology is popular because it looks like a star but acts as a ring that uses a central hub type device, but the internal wiring makes a ring. Physically it looks like a star, but logically it acts as a ring topology. Logical topology. Access method. This low selection section will identify what are known as access method. An access method determines how a host will place data on the wire. And does the host have to wait its turn, or can it just place the data on the wire whenever it wants? The answer is determined the three major access methods: CSMS, CD, CSMS, CA, token passing. First, CSMS-CA, full form Cases multiple action with collision detection. It is one of the most popular access methods in use today. With CSMS-CD, every host has equal access to the wire and can place data on the wire when the wire is free from traffic. If a host wishes to place data on the wire, it will sense the wire and determine whether there is a signal already on the wire. If there is a host will not wait to transmit data. If the wire is free, the host will send the data. The problem with the process just described is that if there are two systems on the wire that sense the wire at the same time to see if the wire is free, they will both send data out at the same time if the wire is free. When the two pieces of data are sent out on the wire at the same time, they will collide with one another and the data will be destroyed. If the data is destroyed in transit, the data will need to retransmit it. After a collision, each host will wait a variable length of time before retransmitting the data. They don't want the data to collide again, thereby preventing a collision the second time. When a system determines that the data has collided and then retransmit the data, that is known as collision detection. CSMS-CA, area sense multiple access with collision avoidance, is not as popular as CSMA-CDI, and for good reason. With CSMA-CDI, before a host sends data on the wire, it will sense the wire as well to see if the wire is free signal. If the wire all Ethernet environments use CSMA-CD as access method is free, it will try to avoid collision by sending a piece of dummy data on the wire first to see whether it collides with any other data. If it does not collide, the host in effect assumes if my dummy data did not collide, then the real data will collide and it submits the real data on the wire. Then token passing with both CSMA and CSMA the possibility of collision is always there, and the more hosts that are placed on the wire, the greater the chance of collision. Here are token passing. You guys are seeing. The more hosts that are placed on the wire, the greater the chance of collision, because you have more systems waiting for the wire to become free so that they can send their data. Token passing takes a totally different approach to deciding on how a system can place data on the wire. With token passing, there is an empty packet running around on the wire the token. In order to place data on the wire, you need to wait for the token. Once you have the token and it is free of data, you can place your data on the wire. Since there is only one token and host needs to have the token to talk, it is impossible to have collision in a talking passing environment. For example, if workstation and one wants to send data on the wire, the workstation would wait to for or the token, which is circling the network millions of times per second. Once the token has reached workstation 1, the workstation would take the token off the network, fill it with data, mark the token as being used so that no other system try to fill the token with data, and then place the token back on the wire. Heading for the destination host, all system will look at the data but they will not process it, since it is not destined for them. However, the system that is intended destination will read the data and send the token back to the sender as a confirmation. Once the token has reached the original sender, the token is unflagged as being used and released as an empty token onto the network. So today I will complete topology. Next class I will complete networking devices. Thank you guys. Please like my channel and subscribe for more this type of videos, more technical knowledge. Subscribe my channel. Thank you guys.